Welcome back, focused learners. We are diving into another explainer today, and honestly, I am absolutely pumped you're here. We are going to be looking at something that, well, it literally feels like peering straight into the future of the internet. We're unpacking a highly confidential internal memo from LINKSPREED LLC. It's dated May 18th, 2026, and it announces the completion of Phase 1 for something they are calling Project Arctic. Now, if you've been tracking the evolution of decentralized networks at all, you know the term Web 4 gets thrown around a ton. But listen, this memo, it is not just theory. This is the actual engineering roadmap detailing the creation of a decentralized compute backbone. We're going to break down exactly how this tech is finally moving out of the lab and into the real world.
Okay, let's dive into this. Here's our roadmap for today. First up, welcome to Web 4. Second, the ARCD routing revolution. Third, OS and data sovereignty. Fourth, we'll enter the closed alpha. And finally, the road ahead. This structure is really going to help us decode this highly technical jump from a localized lab sandbox into a live controlled alpha test.
Starting things off with Section 1. Welcome to Web 4, Layer 3 Compute and Routing.
You know, to really grasp why Project Arctic is such a big deal, we have to talk about the foundational problem with our current internet. Right now, the web relies heavily on these massive, centralized choke points. If a central server goes offline, or if some commercial cloud broker decides to change their rules, huge chunks of the internet just outright break. It's fragile. Project Arctic is LINKSPREED's incredibly ambitious attempt to build a completely new, decentralized compute backbone to fix that exact vulnerability. And the massive news from this memo is that Phase 1 is officially in the books. The core engineering team didn't just come up with a cool concept, they've actually validated their proprietary peer-to-peer network. They built the engine, tested it out in the lab, and now they're officially transitioning to a closed alpha. That means real-world testing with geographically distributed nodes. The theoretical stuff is actually becoming operational.
Moving right along to Section 2, the ARCT routing revolution, rebuilding the map.
So, the single biggest hurdle in any decentralized tech is routing. Basically, how do devices actually find and talk to each other if there's no central boss telling them where to go? Well, think about how it works right now with centralized DNS and commercial cloud brokers. It's kind of like a giant central post office. Every single piece of mail, your data, has to go through this one hub to find its destination. The glaring problem there is that the post office can read your mail, they can lose it, or they can even refuse to deliver it. Our Kick solution completely flips the script with domainless architecture and sovereign routing. Instead of that central post office, imagine hiring an armored courier that takes a dynamic, constantly changing path directly to the recipient. This completely removes the need for centralized DNS servers. It is 100% peer-to-peer. Now, what's really interesting about this is how they actually pull it off. They achieve this domainless routing through something called the UIID, or the Unique Individual Identifier. And the memo makes it very clear. This is not just a standard username. It is a cryptographic signature that acts as your ultra-secure network address. It allows nodes in the network to dynamically build localized, cryptographically secure routing tables on the fly. Simply put, the UIID is the magic key that lets devices securely discover and authenticate each other entirely on their own. They're completely bypassing the middleman.
Which brings us to Section 3, OS and data sovereignty, locking the doors. All right, so we understand how Arctic rebuilt the map using the UID, but now we need to look at the vehicle that's actually driving on that map, the Arctic operating system. The memo outlines some frankly mind-blowing integration milestones here. First off, platform portability. This OS isn't locked down to one specific crazy expensive server type. They've actually confirmed it runs perfectly across incredibly diverse hardware. We are talking low-power single-board computers, clunky legacy hardware, and even early developmental prototypes for something they refer to as the W4 book. But honestly, that last point is the real game changer. Edge compute provisioning. This means the OS lets individual nodes advertise their available CPU and RAM to the broader mesh network. This right here is the absolute bedrock of decentralized task distribution. Your device isn't just consuming the internet anymore, it's actively powering it.
And that brings us to a massively important question, one I really want you to think about for a second. When you send a file, a message, or even a compute task across the current internet, who actually owns your data while it's in transit? In our centralized model, the servers routing your data are constantly caching it, scanning it, or analyzing it. You might own the file when it's sitting on your hard drive, but the second you hit send, you basically lose control.
LINKSPREED tackles this head-on with a concept they call origin-anchored security. Complete data ownership remains right at the edge. Because of those cryptographic UID credentials we just talked about, all transaction and transit data is signed locally.
The node-to-node routing works without anyone ever caching, reading, or modifying your data while it's moving. It's just passing a locked safe down the line. That guarantees true, uncompromised data sovereignty. So the crucial point is, we're ready for Section 4. Enter the closed alpha, taking it for a test drive.
All of this incredible engineering, the domainless routing, the UID, the origin-anchored security, it's no longer just on a whiteboard. The peer-to-peer fabric is up and it is ready for some serious stress testing. They're expanding the network by deploying roughly 100 private testing nodes, distributed specifically across the DACH region, so that's Germany, Austria, and Switzerland, as well as the United States. And this whole rollout is being managed by a master reseller, a Lotus Management AG. But the coolest part is what they're actually testing out there: resiliency and self-healing. They want to see how fast this network adapts when nodes just abruptly drop off. They are literally unplugging machines to see if the network survives. Plus, they are running baseline trials for compute offloading, basically testing that microcompute task sharing between edge nodes we mentioned earlier. It's a highly restricted phase, relying entirely on select builders and partners to log performance.
And that leads us perfectly into Section 5, the road ahead. What's next for Web 4? As we wrap up our deep dive into this internal memo, we naturally have to ask, how does LINKSPREED plan to scale this? How do they get from a tight 100-node closed alpha to a massive public release? Well, and this brilliantly illustrates their strategy. They're taking a super methodical approach. Step 1 is alpha dispatches. The chosen testers get a highly secure encrypted package with the ArcticOS alpha image and their temporary UIID credentials. Step 2 is the telemetry setup. Testers hook into a secure developer portal so LINKSPREED can keep an eye on packet latency and routing efficiency in real time. Finally, Step 3, the feedback loop. They are running weekly technical reviews to compile all these performance metrics. Every single piece of data pulled from this alpha is going directly toward preparing the network for the upcoming open beta release.
You know, the internal memo actually signs off with this exact line: building the decentralized compute backbone for Web 4. Now, in a lot of corporate documents, a line like that, it's just a flashy marketing tagline. But when you look at the sheer engineering milestones they've hit in Phase 1, the dynamic UIID routing, an OS that runs on almost any hardware, and true origin-anchored security, this is a literal description of what Project Arctic Layer 3 is actively doing right now. They are fundamentally rewiring how our devices interact.
So I want to leave you with this final thought today. As Web 4 actively shifts computing power away from these giant centralized servers and puts it back into our own hands, how will true data sovereignty change your relationship with the internet? When you know for a fact, mathematically, that no middleman can read, alter, or stockpile your data, how does that change the way you use the digital world? It is a fascinating question, and one we are all going to have to answer sooner rather than later as Project Arctic charges toward its open beta. Keep learning, keep questioning, and I will see you in the next explainer.